Today, our topic of discussion is resolution. Now, the question is, what is resolution? You can say that resolution is a theorem proving technique, and this theorem proving technique proves something by using the concept of contradiction. So, if you ask me that what is the definition of this resolution, I can say that it is a theorem proving technique that proceeds by building refutation. And the meaning of refutation is the proof by contradiction. Now, here the point is why we need resolution. Resolution is needed when we have various given statements and we need to prove some conclusion using those statements. At this point of time, we need resolution. And you have to remember one of the key concept of proof by refutation is unification. So, by using the concept of unification, we can perform resolution so that we can derive some conclusion from given set of statements. At this point of time, it is clear that we should have some given statements which are known as facts. So, using these facts or using this knowledge, we can derive some conclusion. So at this point of time, we are not deriving. Here we have some AI system which will help us to infer so that we could conclude here. So now what are the basic steps of resolution? Resolution is a very simple algorithm. It has 4 steps. The first step is whatever facts are given to you, you have to convert those facts into first order predicate logic or first order logic. So the first step of resolution is conversion of given facts into first order logic. Now what is the meaning of conversion of first order logic? You have to remember, because we know that we have 2 kinds of logic, predicate and proposition. So which kind of conversion we are expecting here? So now I'm giving you one example so that you could understand the point number 1 or step number 1. Say the statement is given as the humidity is high or the sky is cloudy. So here the question is, how could I convert it into first order logic? See, in this statement, I do not have the concept of quantifiers. Means in this statement does not include all, some, this kind of words. So as a result, simply what I can do, I can use propositional conversion. That is, the humidity is high. I can write or I can consider this line as say Q, or the sky is cloudy. So this line can be considered as R. So as a result, the conversion of this fact will be Q or R. So this is a simple conversion. So this is one kind of first order logic conversion. However, now consider a fact which is given as, say, John likes all kind of food. So now if we want to convert this statement into first order logic, then what kind of conversion we will use? So this English statement will consider, or it includes, a word which is known as all. So we have to use the universal quantifier here. So at this point of time, the first order logic conversion will be like all kind of food. It means we have to use all quantifier, and then I have to use one variable which signifies the food. So I have to write what is x. So x is a food because all kind of food I have to represent. So I will write food x. And we know that whenever all quantifier is used, the prime connective will be implication sign. And this is your subject John, and John likes all kind of food. This is predicate. So what is the essence of this statement? Likes. Who likes what? John likes food. So here food, all kind of food is represented by a variable x. So therefore I will write here likes John x. Since in step number 1 of the resolution algorithm states that we have to convert the given facts into first order logic, what kind of conversion we will use, it depends on what kind of statement is given. However, today, I will only consider this kind of conversion because whenever we want to apply resolution algorithm on this kind of statements, then we have to further subdivide this algorithm in some steps. So today I will only consider the part 1, that whenever we have this simple kind of representation. So this is your step 1. Now, what is the step 2 of the resolution algorithm? So, step 2 of this resolution algorithm will be, then we have to convert this FOL statements into conjunctive normal form. For the next step is we have to convert the first order logic statements into CNF, conjunctive normal form. Now, what is the definition of conjunctive normal form? Here, conjunctive normal form means we will have some clauses. Clause comprises of some literals. So, these are known as literals. And these two clause will be connected via disjunction, that is or. And inside this clause, we will have and. So the definition of conjunctive normal form is whenever we have more than one clause and they are connected via disjunction. At this point of time, it is known as conjunctive normal form. So we may have more than two clauses with more than one literals which are connected via and in order to perform conjunctive normal form, always you have to remember all the clauses should have disjunction in between them. That is, we should have or. So, the second statement is whatever FOPL statements we have derived or we have converted, it should be converted to conjunctive normal form. So, after the first step and second step, the third step is we have to negate the statement that we need to prove. Now, this statement is difficult to understand. Now, I will give you one example. And the fourth step is we know that we have to always draw unification tree or resolution graph so that we could prove something. So at the time of proving, we have to design the unification tree, and it is the fourth step. So I'm just writing the algorithm step 5. So first is your conversion of facts into first order logic. Second, convert FOL statements into conjunctive normal form. And the third step is we have to perform negation. We have to negate the statement which needs to prove, and this is known as proof by contradiction. And the fourth step is we have to draw the resolution tree, which is known as unification. Now, to understand these steps, I have to take some example. So, I have to consider some of the examples. So, we know that whenever we want to perform some resolution algorithm, some facts should be given. Say, we have some given facts. The first one is the humidity is high or the sky is cloudy. This is the first fact given to us, but we know that in order to perform resolution algorithm, we need more facts. So the second fact given as if the sky is cloudy, then it will rain. Then we have two more facts, that is if the humidity is high, then it is hot. And the fourth fact is given as it is not hot. Now, this will be your given facts. However, the intention of this resolution algorithm is to prove. To prove what? We have to prove some conclusion. So, what I am going to prove, it should be given. So, whatever we are going to prove, that is known as goal. So, what is the goal? What we have to prove? That we have to prove it will rain or not. So goal is given, it will rain. So here my point is whenever we are going to perform resolution algorithm, remember one point, facts will be given and it will be a set of facts, and also what we are going to prove by using resolution algorithm, that goal should be given to you. Now, these are the given conditions. Now, at this point of time, on this example, I will apply these four steps so that I could conclude this goal. Now, how could I apply this? The first point is we have to convert the facts into first order logic. Now, how could I convert? See, the first statement is the humidity is high or the sky is cloudy. So we do not have any all or some word. I will use simple propositional logic conversion. So the humidity is high. I will consider it as P because for propositional logic, whatever first fact is given to you, we will consider that first fact as P. So this is a rule, or you can say it is a convention also. Now we have or in between and the sky is cloudy. So I am assuming is at Q. So the first fact is converted to FOL, first order logic, and that is P or Q. Now come to the second fact. If the sky is cloudy, so if the sky is cloudy, see here the sky is cloudy, this statement is considered as Q already. So this line, the sky is cloudy, will be also assumed as Q. And then it will rain. So this is the new statement. So it will rain means I am consider it as R. Now since we have if and then, so I will write it as Q implies R. Means if the sky is cloudy, if Q, then R. So now consider the humidity is high. The humidity is high according to the first fact, it is considered as P. And then it is hot. it is hot, it is a new statement, so I'm consider it as S. So since we have if and then, so I will write if the humidity is high, then it is hot. So it will become P implies Q. Now consider the fourth fact. It is not hot. So it is hot, it means S. So it is not hot means not of S. Or you can write it as not of S. Now, according to this first step, we have to convert each and every fact into FOL. Now you have to also remember that whatever goal is given to you, also you have to convert it into FOL. So it will rain. How can I consider it as it will rain? So here we have one statement that it will rain is considered as R. So it will rain means again this representation will be R. So the first point or the first step is over. Now come to the second step. Convert the FOL statement into conjunctive normal form. Conjunctive normal form means whatever we have, clause or single literals, they should be connected via disjunction. So here the first conversion, it is already in CNF because literal P and literal Q is connected via disjunction or. However, the second fact Q implies R is not in CNF. So we have to convert it. How we can convert it? We know that Q implies R can be further abbreviated as not Q or R. So we have to convert it into this abbreviation. And here the literal not Q and R is connected via disjunction. So therefore the second fact is also converted to CNF. Similarly, we can also convert the third fact P implies S into CNF. That is not P or S. So now this abbreviation is in CNF. And what about the rest? So in this case, these are the single literals. So no need of converting them into CNF. So step number 2 is done. Now, what is the meaning of this step number 3? Negate the statement which we need to prove. What we are going to prove? This is the goal which is given to us. We have to prove this goal. So here it is written that negate the statement which we needs to prove. So we need to prove R, therefore we have to negate this R. So we have to write not R. So according to step number 3, in simple words, that is whatever goal is given to you, you have to negate your goal. So since R is my goal, here I am negating the goal. Now we have to learn the fourth step, how we can draw the resolution tree or how we can perform unification. So up to this, we know that whatever we have gathered and whatever we have converted, now using these components, we have to create this unification tree. So let's check what we have right now so that we could apply step number 4. So up to this, we have gathered the first fact as P or Q, and the second fact as not Q or R after conversion, and the third fact was not P or S, and the fourth fact was not S, and after negating our goal, it was not R. So now we will learn how to draw the unification tree. Now in order to draw unification tree, you have to pick two facts at a time in order. So I will pick the first two fact P or Q and not Q or R. so that I could draw the unification tree. So at this point of time, this q and not q means literal q and negation of literal q will be cancelled out, and the remaining will be p or r. So at this point of time, I will pick the fact number 3. So the fact number 3 is not P or S. Now I will try to draw the tree. At this point of time, the literal P and negation of literal P will be cancelled out, and the remaining will be R or S. Now I will pick the fourth fact. So what is the fourth fact? Not S. Now I will try to draw the unification tree. So at this point of time, S and not S will be cancelled out. So what is remaining? Remaining is R. And now, whenever your facts are over, then we have to consider the goal. So after negation, our goal is not R. So I will pick the goal. So our goal is not R, and then as a result I will find phi, because literal r and not r will be cancelled out. This phi is known as null. So at this point of time, what we have concluded, now pay attention to this point. So after applying this proof of reputation, or after applying the contradiction on the goal, that is not r, the problem is solved and it is terminated, that is the unification tree is terminated as null clause, which is known as phi. So hence at this point of time I can say the goal is achieved, because our intention is to find out the goal. So since null is achieved, we can say that our goal is achieved. And goal is achieved means what? What is goal? Negation of R. Means we can say that thus negation R is achieved. And what is the meaning of negation R? R means it will rain. Negation R means it will not rain. So goal is achieved means, since we are performing proof by contradiction, means not R is achieved. So from this what we have concluded by using these facts, that it will not rain.